we have been working with the volume of prisms. We've learned how to calculate the volume of a rectangular prism, and we've also learned how to calculate the volume of a triangular prism. Volume is what fits inside a 3D shape. So if you filled up the shape, how much would fit inside? That's what volume is. What we're going to talk about today is surface area. So surface area is around the outside of the shape. So if you thought about, wrapping your shape up in wrapping paper, the amount of wrapping paper it would take to cover all of the sides of your shape, that's surface area. So if we want to cover all of the sides of the shape, we have to make sure we account for all of the sides of the shape. So surface area is the sum. Remember, sum means addition. The sum of the areas of all of the faces or sides of a 3D shape. So basically the idea is we want to cover all of the sides. So if you think of this like a Christmas present that you're wrapping, we want to make sure we don't leave any sides exposed. We don't want anybody able to peek inside. So what we're going to talk about is we're going to look at a couple of examples with a rectangular prism and a triangular prism so you can think about what does that look like? What is that process of finding all of the sides, the outside area of the shape look like? So here we go, rectangular prism. So a rectangular prism has really 3 different shapes of sides to it. So I'm going to do a little bit of color coding. So we have the front and the back are the same size. So we're going to have the front slash back because the front and the back are both the same. So if we find the front, the back's going to be the same size. We also have the top and the bottom of the shape. So this is the top of the shape. And again, the bottom of the shape is going to be the same size. So we have the top and then a matching bottom. And then we also have the ends or the sides of the shape. So that would be right here. So this is the right side of the shape, but it also has a matching left side that is the same size. So that means that we have 6 different sides that we have to cover. The front, the back, the top, the bottom, the left, and the right. The nice thing though is since they come in pairs, I actually only have to do 3 calculations because the front and the back are the same size. So once I find one, I found both. Same with the top and the bottom and the left and the right. So what we're going to do is we are going to go through and we're going to find the area of each of these sides. So the front and the back are both rectangles, and they are both, we're going to take the units off. We know we're working in inches. We'll put them back on in just a minute. They are both 4 by 10. So if we take or find the area of that, area of a rectangle, length times width, 4 times 10 is going to give 40. But we need 2 of those, one for the front and then another 40 for the back, right? So the front and the back are both going to be 40. So now we're going to do the top and the bottom. So it's actually the bottom of the shape that's labeled, even though we highlighted the top in green. But the top and the bottom, if you look at the diagram, so it's this one. We're going to have to stagger these a little bit so we have room to work. The top and the bottom are both 10 by 3. Well, 10 times 3 is 30. So back, top, bottom. Now we have to do the same thing with the left and the right. So this 4 can carry over to right here. So sometimes you have to kind of match measurements up. So the left and the right side are both these smaller rectangles that are 3 by 4. So that means that 3 times 4 is 12. So the left and the right are both 12. So there's all 6 sides. So we have 2 40s, 2 30s, and 2 12s. So since surface area is just the total of all of those, now that we've found all the sides, what we're going to do is we're just going to add them up. So if you add them up, 40 and 40 makes 80, 30 and 30 is 60, 12 and 12 is 24. So 80 plus 60 plus 24, you get 164. Now we have to think about our units. So I gave the analogy of wrapping a present because it helps you to think about surface area. So surface area is basically like how much paper would it take to cover all the sides of your shape. Well, that paper lays flat. We don't measure it two-dimensional, so we would use area units to calculate surface area. So area units are square units. So since we were measuring this in inches, our answer would be in square inches. And I'm going to use the abbreviation for square inches. So make sure that you're paying attention to units and getting the correct units on your answers. So you should have correct area units on surface area and correct volume units on volume. So the surface area, or in other words, what it would take to completely cover all of the sides of our rectangular prism, is 164 square inches. Since we also talked about triangular prisms, we're going to try this with a triangular prism as well. So this one, I am going to have to give you a quick number that I'm going to have you add in. So there is a way to calculate this side right here. This is going to be the same side. This is equilateral. So there is a way to calculate that. We haven't learned about it yet, so I'm going to give that to you to make sure that you have it. But we're going to need it in order to find the sides. So those sides are about 17. So we're going to use 17 feet for those. It's actually 17.09, but we'll say about 17 feet. So this is going to get us pretty close. So, triangular prism. It has the triangles on either end. So we're going to have the two triangles. So triangles times 2, because we have one on the front and one on the back. So the triangles, to get the area of those, so sketch our triangle. So triangle we know is base times height divided by 2. So this triangle has a base of 13, a height of 11. So to get the area of this triangle, we would do 13 times 11, but then we have to divide it by 2 because that is our area formula for a triangle. So 13 times 11 is 143. But we have to divide that by 2. So each triangle is 71.5. But we have 2 of those triangles, right? So we've got kind of the front and the back. So we've got 2 of those triangles. They're both going to be 71.5 square feet. Now we have to deal with, so a triangle is always going to have 3 sides because a triangle has, basically there's 3 sides to the triangle, and each of those 3 sides is going to have a rectangle coming off of it. So we've got these 3 rectangles that are kind of connecting the triangles on either end. We have to find the area of each of those rectangles. So in this case, so we've got this rectangular side. Now in this case, because our triangle is an isosceles triangle, so these sides are both the same length, that means that this one kind of side hiding over here where that yellow arrow is, that's going to be the same size as this other yellow side. If this were a scalene triangle, then each of the 3 rectangles would be a different size and you would have to calculate them all individually. But we can cheat a little bit because this is isosceles. So this is going to basically be the left side and the right side. Since it's laying down, you could kind of visually see right and left. So those are both rectangles. So the rectangles are 17 feet tall and 15 feet wide. So area of a rectangle is just 17 times 15. So that makes it nice and simple. And that gives an answer of 255. And again, since this side and this side hiding back here are both the same size, we don't have to calculate them separately. We can just say, okay, the left side kind of hiding out of view there is going to be 255, and then the right side is also going to be 255. Now, the tricky thing, you can't see it here, but it is sitting on one side that is on the bottom. So it's got this bottom side here. We'll kind of highlight it in green. So this bottom side that's hiding out of view, but we can't forget about it. So that's the tricky thing with 3D drawings, is that sometimes you have to stop and think about, okay, are there any sides that I know are there that are just kind of hiding because they're being covered up by other sides in the picture? So you have to make sure that you get all the different sides. So this does have a bottom side. It's the side that it's resting on. So with that highlighted in, you can kind of see, okay, that one's going to be 13 by 15. So that's going to be a 13 by 15 rectangle. And again, rectangle, length times width. So that makes a nice, quick, simple calculation. So 13 times 15 gives us 195. And we only have one of those bottom edges, so that's going to be the bottom. So 195. So now what we have to do is we have to just take all of these things. We figured out all the sides, and we just have to add them all up. So a triangular prism will always have 5 sides. So that's a good way to check and make sure. You should be adding up 5 numbers for a triangular prism, and you should always be adding up 6 numbers or 6 sides for a rectangular prism. So if that helps you to check your work to make sure you didn't miss any sides. So a triangular prism will always have 5 sides, the 2 triangles and then the 3 rectangles that are connecting those 2 triangles. So our last step is just going to be to add all of this up. So 71.5 and 71.5 is 143. Plus our left and right, 653, plus the 195 gives us a grand total of 848. And again, these are square units. Since we're measuring in feet, our square units would be square feet. So 848 square feet. So that is the idea behind surface area. So basically the process for surface area that will work for any prism is to go through and individually look at all the sides of the prism and find the area of each side and then just add them all up. But again, the thing you have to be careful with is make sure you don't miss any sides. So a triangular prism, you should be adding up 5 different sides. And a rectangular prism, you should be adding up 6 different sides. So you are going to work on an assignment today that is going to let you